Good day, Grade 7. Today's discussion will be about Science 7, Quarter 4, Module 5, The Earth's Motion. The content of this video is taken from the self-learning modules produced by the Learning Resource Management and Development System of the Schools Division of Bulacan. Objectives: relate the tilt of the Earth to the length of daytime and relate the length of daytime and the amount of energy received. At the end of this module, you are expected to 1. Describe the Earth's motion. 2. Compare the heat received by the different parts of the Earth. And 3. Illustrate the Earth's position with respect to the Sun. What I know. Choose the letter of the best answer. Write the letter of your choice on your answer sheet. See pages 2 to 3 of Quarter 4, Module 5. What's in? Arrange the jumbled letters in each number to form the word that is being described in the statement. Number 1. These are wind system. Answer: monsoons. 2. This is also known as amihan. Answer: northeast monsoon. Number 3. This is also known as habagat. Answer: southwest monsoon. 4. Wind blowing towards the sea from the land. Answer: land breeze. 5. Wind blowing towards the land from the sea. Answer: sea breeze. What's new? Read and analyze the illustration below. Answer the questions that follow. I think the moon circles the earth, while the earth circles the sun. The moon circles the earth, while the sun circles them both. Guide question. Number 1. What are the heavenly bodies being discussed in the picture? Answer: sun, earth, and moon. 2. From the given statements in the dialogue, which heavenly body is at the center as the others revolve around it? Answer: sun is at the center. And number 3, which statement is accepted today? Statement A. The motion of the earth. Why do we experience day and night? Imagine a line passing through the center of the earth that goes through both the North Pole and the South Pole. This imaginary line is called an axis. The earth spins around its axis just as a top spins around its spindle. This movement is called rotation. One complete rotation of Earth is equivalent to 24 hours. It rotates in a counterclockwise direction from west toward the east. Day and night are caused by the Earth's rotation on its axis. It is day on the side of the Earth that is facing the sun, and it is nighttime on the side of the Earth facing away from the sun. As the Earth rotates on its axis, it also moves around the Sun in its elliptical orbit with a speed of about 105,600 kilometers per hour. The movement is called revolution, or the travel of a heavenly body around the Sun. The revolving body must finish up to the point where it started to complete one revolution. The Earth takes 365 and 1/4 days, or approximately 365 days, 5 hours, and 48 minutes to make one complete revolution around the Sun. During the leap years, it takes 366 days to complete its revolution. For Earth to make one complete revolution around the Sun, it takes 365.24 days. This amount of time is the definition of 1 year. So one complete revolution is equal to 1 Earth year. If the Earth revolves around the Sun in an elliptical manner, there is a point in its revolution that the Earth is farthest or nearest from the Sun. When the Earth is closest to the Sun, it is said to be at perihelion. Earth is closest to the Sun at the beginning of January at about 147 million kilometers. During perihelion, the northern hemisphere points away from the sun and receives less heat and light, while the southern hemisphere receives more heat and light than usual. At the time of perihelion, Earth is about 147 million kilometers away from the sun. On average, Earth's distance from the sun is 149 million kilometers. As the Earth continues to move around the sun, there is a point where Earth is farthest from the sun. This point is called aphelion. Earth is farthest from the sun in July at about 152 million kilometers. During aphelion, the northern hemisphere points toward the sun where it receives much energy, making it warmer. The southern hemisphere points away from the sun, receiving less heat that makes the temperature low. When our planet reaches aphelion in July, it will be 152 million kilometers away. Perihelion and aphelion don't cause the seasons, but they do affect the length of the seasons. The distance of the Earth from the Sun affects the energy received by the Earth in a particular day, but not the whole year. It is the Earth's tilt that has a greater effect on the amount of energy received by the Earth year-round. The tilt of the Earth's axis by 23.5 degrees causes the northern hemisphere and the southern hemisphere to be away or towards the sun. Today, the Earth's axis is tilted by 23.5 degrees from the plane of its orbit around the sun, but this tilt changes. During a cycle that averages about 40,000 years, the tilt of the axis varies between 22.1 and 24.5 degrees. Because this tilt changes, the seasons as we know them can become exaggerated. More tilt means more severe seasons, warmer summers and colder winters. Less tilt means less severe seasons, cooler summers and milder winters. The tilt in the Earth's axis is oriented towards the sun in certain months, such as during the month of June, and is oriented away from the sun in other months, such as during December. This tilting of the Earth's axis and revolution of Earth around the sun cause the difference in the amount of light and heat received from the sun by the different parts of the Earth. If Earth is not tilted, then the various parts of Earth would receive the same amount of light during its travel around the sun. Earth's tilted axis causes the seasons. Throughout the year, different parts of Earth receive the sun's most direct rays. So, when the North Pole tilts towards the sun, such as during the month of June, then it is summer in the northern hemisphere. And when the South Pole tilts towards the sun, such as during the month of December, then it is winter in the northern hemisphere. Figure 3 shows that the Earth revolves around the Sun in a counterclockwise direction. The positions of the Earth in the figure shows the quarters of the year where parts of the Earth experience different temperatures. In March 20 to 21, Earth's northern hemisphere is tilted away from the sun, while the southern hemisphere is tilted towards the sun. During this time, the sun's direct rays fall on the equator. This marks the beginning of spring in the northern hemisphere. In the illustration, we could see that during the month of March, the northern hemisphere is tilted away from the sun, while the southern hemisphere is tilted towards the sun. During March, the sun's direct rays fall directly on the equator. So in the northern hemisphere, days are becoming longer and nights are becoming shorter in preparation for the next season, which is summer. So in the northern hemisphere, it is springtime. In the southern hemisphere, days are becoming shorter and nights are becoming longer in preparation for the next season, which is winter. So in the southern hemisphere, it is autumn. So during the month of March, in the northern hemisphere, it is springtime. And during the month of March, in the southern hemisphere, it is autumn. If you notice, during September 22 to 23, the northern hemisphere is tilted towards the sun and the southern hemisphere is tilted away from the sun. During this time, the sun's direct rays fall on the equator. This marks the beginning of autumn. In the illustration, we could see that during the month of March, the northern hemisphere is tilted towards the sun, while the southern hemisphere is tilted away from the sun. So during the month of September, days are becoming shorter and nights are becoming longer in preparation for the next season, which is winter. So in the northern hemisphere, during the month of September, it is autumn. In the southern hemisphere, days are becoming longer and nights are becoming shorter in preparation for the next season, which is summer. So, during the month of September, in the southern hemisphere, it is spring. In these two positions of the Earth, during the month of March and during the month of September, the sun shines equally in the northern and southern hemisphere. This is called equinox. Equinox came from the Latin word equus, meaning equal, and nox, meaning night. During equinoxes, the hours of daylight and the hours of darkness is almost the same everywhere on Earth. So during the month of March and during the month of September, the sun's direct rays fall directly on the equator. And this is the reason why we have equal hours of daylight and nighttime. So we call this point in the Earth's revolution around the sun as equinox. So during March, it is called vernal equinox. And during the month of September, it is called autumn equinox. Figure 3 shows that during December 21 to 22, the sun shines directly on the southern hemisphere and indirectly on the northern hemisphere. This is the time when people living in the northern hemisphere experience the shortest daylight and winter begins. In the illustration, we could see that during the month of December, the northern hemisphere is tilted away from the sun, and the southern hemisphere is tilted towards the sun. So in the northern hemisphere, days are shorter and nights are longer. Longer nights means more time for cooling down. So in the northern hemisphere, during the month of December, it is winter. Now, in the southern hemisphere, days are longer and nights are shorter. Longer days means more time for heating up. That is why, during the month of December, it is summer in the southern hemisphere. During June 20 to 21, the sun shines directly on the northern hemisphere and indirectly in the southern hemisphere. This is when people living in the northern hemisphere experience the most daylight of the year and when summer begins. So in the illustration, we could see that during the month of June, the northern hemisphere is tilted towards the sun. The southern hemisphere is tilted away from the sun. That is why during the month of June, days are longer and nights are shorter. Longer days means more time for heating up. So in the northern hemisphere, during the month of June, it is summer. Now, in the southern hemisphere, since it is tilted away from the sun, days are shorter and nights are longer. Longer nights means more time for cooling down. That is why in the southern hemisphere during the month of June it is winter. In these two positions, the Earth experienced solstice. Solstice comes from the Latin word sol meaning sun and sistere meaning to stand still. The northern hemisphere during the month of June and the southern hemisphere during the month of December are tilted towards the sun. In the illustration, we could see that during June, it is summer in the northern hemisphere because the North Pole is tilted towards the sun. After 6 months, during the month of December, it is summer in the southern hemisphere because the South Pole is tilted towards the sun. Seasons in the northern hemisphere is opposite to the southern hemisphere. If it is summer in the northern hemisphere, then winter is experienced in the southern hemisphere. Likewise, if it is winter in the northern hemisphere, it is summer in the southern hemisphere. This also happens during equinoxes. In the illustration, during the month of June, it is summer in the northern hemisphere. In the southern hemisphere, it is winter. After 6 months, during the month of December, the northern hemisphere experiences winter, while the southern hemisphere experiences summer. During the equinoxes, during the month of September, it is autumn in the northern hemisphere, while in the southern hemisphere, it is springtime. After 6 months, during the month of March, it is springtime in the northern hemisphere and it is autumn in the southern hemisphere. The tilt of the Earth's axis by 23.5 degrees causes change in temperature in the northern and southern part of the Earth, but not in the places near the equator. Equatorial areas experience little seasonal change. The Philippines is one of the countries located near the equator. We do not experience 4 seasons, we only have wet and dry seasons. Twice a year, during the spring and autumn equinoxes, the sun passes directly over the equator. Even during the rest of the year, equatorial regions often experience a hot climate with little seasonal variation. As a result, many equatorial cultures recognize 2 seasons, and that is the wet and dry season. Let us now discuss the different activities in What's More. Independent Activity 1. Write the word fact if the statement is correct and bluff if it is not. Independent Assessment 1. Draw the positions of the Earth with respect to the Sun according to the descriptions given. Description number 1. The Northern Hemisphere experience equal hours of daylight. 2. The southern hemisphere experience equal hours of daylight. 3. Winter begins in the southern hemisphere. 4. Summer begins in the northern hemisphere. And 5. The northern hemisphere experience equal darkness. Independent Activity 2. Where's my label? Label the parts of the given illustration below. Choose your answer from the word pool. So your choices are sun, northern hemisphere, southern hemisphere, rotation, axis, equator, north, east, west, and south. Independent Assessment 2. Hunt for fun. Look for the hidden words that are being described in the statements below. Statement 1 to 10 are found below our Lupo word puzzle. In order for you to answer all of this, you need to look for the terms in the puzzle. Independent Activity 3. Fill me in. Supply the missing letters to complete the word being described. Independent Assessment 3. Match the description in column A to the correct term in column B. So your choices are revolution, autumn, equator, rotation, and axis. What I have learned. Complete the given phrase below. I learned that. I realized that what I can do. Outdoor activity. Number 1, observe the amount of heat that you will feel on the following times of the day. A. Early morning. B. Noon. C. Sunset. 2. Go in front of your house and feel the warmth of the sun. Stay for 1 minute. 3. Take note of the height of the sun in the sky in those 3 occasions. Relate the heat that you feel with the height of the sun in the sky. 4. Interview or ask your parents or some older people in your neighborhood about their opinions on the length of the day during summer, April and May, and during December. 5. Make a conclusion based on what you heard from those people you interviewed. And 6. Interview relatives or friends that you know are working abroad. Ask them about the seasons there and classify the countries as to the prominent weather experienced in that place. Assessment. Choose the letter of the best answer. Write your answer on your answer sheet. See pages 13 to 15 of Quarter 4, Module 5. Additional activity. Performance task number 4.5. Brain gauge. Write a paragraph with 5 to 10 sentences that will explain your thoughts about the guide questions given below. Guide question number 1. Why do we experience extreme heat? 2. What could be the effects of extreme heat to us? And 3. How does it affect our environment? So for the additional activity, you will be graded based on this rubric. Criteria, coherence, 5 points. Content of the essay, 5 points. Organization, 5 points. Grammar and spelling, 5 points, for a total of 20 points. Science 7, Quarter 4, Module 5, The Earth's Motion. Answer the following on your answer sheet. What I know, what's more, independent activities 1, 2, 3, independent assessments 1, 2, 3, what I have learned, what I can do, assessment, and additional activities. The additional activity will be your performance task number 4.5. Upload your answer sheets in PDF format in your Google Drive folder. The path is Science 7, Quarter 4, Module 5. Or send them in JPEG format to my messenger. Thank you for attending our Science 7 online class. God bless you all.